Greetings viewers, welcome to Radioactivity. As for today, we are going to concentrate on science paper 1, which was GC 2024, section C. So we are going to solve question C3. So question C3 was on radioactivity, and radioactivity I've already taught full topic. You can look for the video. So question A will say define nuclear fusion. So nuclear fusion, this is the combination of right nuclei to form large nuclei or to form heavy nuclei. So we are going to write the definition for nuclear fusion. Nuclear fusion is the combination of right nuclei to form heavy nuclei. So this was the definition which was needed on question A. We are going to move on to question A2, which was saying state two similarities between nuclear fusion and nuclear fission. So the similarities are in both reactions, the reactants are unstable. So that is number one similarity. In both reactions, reactants are unstable. Then the second similarity, we are going to say in both reactions, energy is produced. So in both reactions, energy is produced. So these are the answers which were needed on question 2. So we are going to move on to question A3, which was saying write an equation for of a reaction of hydrogen and hydrogen to produce helium. So this reaction was an example of nuclear fusion. So when you understand the nuclear fusion, it is going to be easy for you to write this reaction. So we are going to write this reaction using this top part of the pot. So the question is saying write an equation for the reaction of hydrogen and hydrogen to produce helium. So we are reacting hydrogen and hydrogen. So these are isotopes of hydrogen. Then this react with this hydrogen. So this reaction is an example of nuclear fusion. As we said, nuclear fusion is a combination of right nuclei to form heavy nuclei. So this side, what is going to be formed is going to be a heavy nuclei. So in this example, the heavy nuclei is helium. So helium is going to be produced this side. And as we said on the similarities between nuclear fusion and nuclear fission, we said in both reactions energy is produced. So energy has to be shown. And for this reaction to take place, there is need for a fast moving neutron. So we are supposed to show the fast moving neutron. So this side we are going to have a fast moving neutron. because when you see this reaction coming from this side, there is need for a fast moving neutron to break down helium to produce these two hydrogens. So here we are going to show the fast moving neutron. So this is a symbol for a fast moving neutron, then plus energy. Energy, you just write it in words. So this was the equation which was needed on question A3. We move on to question B. So question B was saying, name a device that can be used to measure nuclear radiation. So nuclear radiation. So a device which can be used to measure nuclear radiation. We have a gigamolar. So we're going to write the answer for B. We have a gigamolar 2. So this was the answer for question B. Then we move on to B2, which was saying which radioactive emission is not deflected by an electric field. So for one to be able to answer this question, one has to understand the charges of the types of emissions of which we have. So we have alpha emissions, then we have beta particle, and then we have lastly the gamma ray. So for alpha, we have positive 2 as the charge. Then for a beta particle, we have negative 1. While for a gamma ray, it is neutral. So a gamma ray, since it is neutral, it is not going to be affected by the electric field and the magnetic field. So the answer for question B2 was a gamma ray. So I'm going to write gamma ray. Then question C was saying a radioactive sample of mass 200 grams has a half-life of 8 days. How much of the sample would have decayed after 32 days? So if you're having challenges on half-life, I've already taught radioactivity. It is a full topic. You can look for the video on YouTube. You are going to find the video on Radioactivity. So we are going to solve this question, which was on half-life. So the question is saying the half-life was 8 days. Then we are told to find how much of the sample would have decayed. So we are told to find the decayed sample after 32 days. And there are some questions on half-life. Some of them do not even need to use the formula. So for this one, I'm not going to use the formula. So you are just going to use our understanding, simple and understanding. So we are told the radioactive sample of mass 200 grams. So here we are going to write mass. Then here we are going to write period, since we have days here, so meaning period, the time taken. So mass we have 200 grams. So when the radioactive sample was 200 grams, the period which passed was not 8 days. So 8 days is said to be the half-life after that 200 grams of that 200 grams. So the period when the mass was 200 grams was 0 days. So this was the original mass of this radioactive sample. So after 8 days, now the mass of this radioactive sample is going to change. So after 8 days, since it has undergone uh, decay, since it has it has decayed after 8 days, the mass is going to change, and the mass is going to change over over 2. So this is half life. So we are going to divide the mass over 2. We are going to have here 100 grams, and the total period given is 32 days, and here we only have 8 days. So again we are going to add another 8 days. So when we add another 8 days to this one, we are going to have 16 days. So after 16 days, we are going again to divide this by 2. We are going to remain with 50 grams. So again, this 16 is not 52. So we are going to add another 8 years, which is going to give us 24 days. So after 24 days, this 50 grams is going again to reduce by 2 over 2. Then we are going to remain with 25 grams. Then this 24 days is not again 52 days. So we are going to add another 8 days. So when we add another 8 days, we are going to reach at 52, which was the amount of days of which the question is requiring us to end. So 52 days, at 52 days, we are going to divide this 25 by 2 to find now the mass which remained after 32 days. So the mass which remained is going to be 12.5. So we have found the mass which remained after 32 days. Now the question is requiring us to find the how much of the sample would have decayed after 32 days. So we are going to get the original mass of the radioactive sample, which was 200 grams. Then we are going to subtract 12.5, since this 12.5 is the amount of mass of a radioactive sample which remained, and here we are looking for the decayed sample. So we are going to subtract 12.5. Then after subtracting this, we are going to find our answer as so we are going to find our answer as 187.2 grams. So this was the mass of this radioactive sample which was decayed. So this was the answer of which question C was looking for. So we are going to move on to question D, which was the last question. State one way of handling a radioactive materials safely. So for this question, we are given 1 mark. So again, in that video where I taught the full lesson on radioactivity, I mentioned ways in which we handle radioactive materials. But for this question, since we only need one way, we are going now to mention the one way in which we can handle radioactive materials safely. So we can handle radioactive materials safely by storing them in lead boxes. Since lead boxes are materials which are even capable. So the answer for question D is by storing these radioactive materials in lead boxes. Since lead boxes are elements or substances which are even capable of stopping emissions of gamma ray. So we are going to write the answer for question D as storing 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 them in lead boxes. So this is all on radioactivity. So this was the full question, which was C3. If you need any more information on radioactivity, you can comment in the comment section. We'll be able to attend to you.